morning, everyone. Screen is visible.
Good morning, sir. Yes, sir.
Good morning, sir.
Good. Okay.
Good morning, sir.
Okay. In last lecture, we have seen this number representation, decimal, binary, octal, and hexadecimal. And what is the base of that system? Digits, right? And then we have seen the conversion from decimal to binary. And then we have generalized that how to convert any decimal number into any representation, right? So generally, whenever you have a decimal number, the whole part that you can process like this. So this is your least significant, and this is are the reminders. So this is first is your least significant bit, and this is your most significant bit. So this way you need to write for whole number. For fraction you need to multiply with that radix or base, and until you get 0 you need to multiply it. And here we are taking the whole number. Point પહેલાનો જે number છે that we are taking, right? In this case you need to write top to bottom. This is your MSB and this is your LSB. So this will change whenever you have a different base or radix, right? Right now we are converting binary, that's why 2. If it is octal, then this will be 8. This will be 8, right? Hexadecimal, then this will be 16. This will be 16. And in that, when you divide with 16, the remainder can be 0 to 15, right? And for 10 to 15 we have a character A, B, C, D, E, F. Okay. So this conversion we have seen, and then we have seen the reverse conversion. Means if any representation is given to you and you want to convert into decimal, right? So we have seen the binary representation, and then we have converted this binary into decimal. So this is the weighted number system. So each position has some value, right? If it's 1 here, then it will add 1 in your number. If this is 1, then this will add 2 in your number. If this is 1, then this will add 4 in your number. This is 1, then this will add 8 in your number. So this is the weighted system, right? Then we have seen this, right? These are the position of your digit. Take that digit, multiply with that base. This is the base raised to position. This way you need to do for all the numbers, right? Once you perform this sum after multiplication, what you will get your decimal number, right? And this is true for if you want to convert from any base to decimal. Okay, so if you have an octal number and you want to convert into decimal, then this base will be changed, right? Radix. Just remember, take the digit, multiply with radix raised to position. આ રીતે કરવાનું. Okay, so this thing we have studied. I will give some example later on કે જે તમે સોલ્વ કરો ને તમને ખબર પડે. Okay, so decimal to any number system, any base, and from any base to decimal. This conversion we have seen. Okay, now suppose you have some octal number, and we have also seen that decimal number hoy in a direct binary. Suppose MCQ કે એવું પૂછાયું છે. In that case you don't require to show this process, right? So in that case you can directly write. So in such cases decimal number આપ્યો છે બાઇનરીમાં કઈ રીતે ડાયરેક્ટ કરવું, that we have seen, right? So this is a 6. So 6, how to convert it? So each position will give you some number. એ આપણે અહીંયા બતાવી દીધી, right? 2 raised to 0, so 1, 2 raised to 1, 2, 2 raised to 2, 4, 2 raised to 3, 8, 2 raised to 4, 16. Now first is 6. 6 ક્યાં આવે? 2 raised to 3 and 2 raised to 2 ની વચ્ચે, right? So now 6 minus 4. Okay, so 4 plus 2 means આ સમેશન તમારે બધું 2 raised to ના ફોર્મમાં થાય એ રીતે કરવાનું. Okay, if it is a 7, then 4 plus 2 plus 1 all are in 2 raised to form. If it is 8, then 8 plus all are 0 0. So in this case 8 4 2 1, right? This is 8. In this case 4 2 1. This is the binary representation of 7 and this is the binary representation of 8. So this way directly you can write. આ રીતે directly લખાય binary representation. Okay. Now next, suppose I have some octal number 6 4 3 base 8. This is the octal number. Now suppose you want to convert this octal number into hexadecimal, means base 16. You want to convert into base 16. So how you will convert? So we know the one process. We know the conversion from decimal to any number system and any number system to decimal. That number system we know, right? Okay, so if we follow that, then first we need to convert this octal into decimal and then from decimal to hexa. Got it? Decimal. So we know this decimal to any number and from any number to decimal. That's why we are taking right now help of decimal. So convert this octal into decimal and decimal to hexa. This way we can do it, but this will take time. This is the smaller number. If you have a larger number, then this will take time, right? So how to do it? Okay, now same way, if you want to convert this octal into binary, I want to convert into binary, then same way, decimal is the common platform, so octal to decimal and then decimal to binary. Same way hexa into binary, so hexa to decimal and then decimal to binary, right? But here there is one observation, right, which can omit this conversion. Decimal વાળું convert કરવાનો તમને omit કરી નાખે. How? 643, this is the octal representation. Okay, now this octal representation, the value ranges from 0 to 7. 0 to 7. So this is the minimum value, this is the maximum value, right? Decimal value kehvaય minimum and maximum. Now if you represent 7, then 7th can be represented as 1 1 1. Binary representation of 7 1 1 1. If we represent 0, then simple 0. But the maximum digit in binary required for octal is 3. Maximum કેટલા 3 જોઈએ, so આપણે આને પણ 3 માં represent કરી દઈએ, right? So if you convert this, then this will go from 0 0 0 to 1 1 1 into binary octal number, right? So using this interpretation, you can directly write from octal to binary, right? So how? So whenever you have an octal number, you need to convert directly into binary, considering this as a decimal number, and represent that with 3 bits. This is most important. You need to use 3 bits, right? How? If you convert this 3 into binary, then that will be 2 plus 1, right? So 2 and 1. But what I said, you need to represent into 3 bits. So put 0. So now it's a 3 bit. Again, if you have a suppose 2, not 2, take 1. If you have a 1, then that is 1, right? So in this case, this will be the binary representation, but this is the octal, so you need to give 0 0. So this way, following this 3, I can write like this: 0 1 1, 4 4 2 1, 3 3 bits, 3 bits, 6 4 2 and 1, 3 bits. So you can see from octal I have directly written the binary representation. I have directly written the binary representation from octal, right? Same way, suppose you have some hexa number. Consider A5F base 16. If you have this hexa number, follow this process for hexa number. It's 0 to F means 15, right? We represent 0 to 9 and A to F, but the value of A to F means 10 to 15. Okay, so that's why I've written 0 to 15. Now if you represent 15, this decimal value into binary, then that will be 15 is 8 plus 4 plus 2 plus 1. This is the 15, means 1 1 1 1. This is a binary representation of 15. 0 0, but the maximum requirement is 4 bits, so you will represent 0 in 4 bits. Okay, so now if I need to convert this, so F means 15, right? So 15 1 1 1 1. Now 5 is 4 0 1, 4 2 1. So 4 plus 1, that is 5, right? So 1 0 1, 3 bits, so you need to put 0. So that will be 0 1 0 1. A means 10. So if you represent in 2 power, then that will be 8 plus 2, right? So 8 4 2 1. So 1 0 1 0. This is what hexadecimal to binary direct conversion, right? If you want to check, you can convert into hexa to decimal and decimal to binary. You will get this number only. Okay, but this way you can directly write. Okay, now observe here what we have done from octal to binary, from hexa to binary. Now we can take the advantage of this binary. આપણે binary નો advantage લઈશું, right? Now suppose if I want to convert this octal into hexadecimal, then what I will take, instead of decimal I will use this binary conversion. Okay, so I will use this binary conversion. The number is 1 1 0 1 0 0 0 1 1, right? This is the binary representation of this octal number. Now I need to convert into hexa. So what I will do, I will start making group of 4 from least significant bit. From least significant bit. Okay. From here, least significant bit. Group of 4. Group of 4. And here also. As this is only 1 bit, so you can add 0. Right? So 4 bits. Now convert this 4 bits into corresponding decimal number. So 0011. So what is this? At position 0, 1, 2, 3 means 2 raised to 3, 8. It's a 0 means it will not add 8. So we will omit 8. 8, 4, 2, 1. 2 raised to 3, 8. 2 raised to 2, 4. 2 raised to 1, 2. 2 raised to 0, 1. So 2 plus 1, 3. 1010 means 8 plus 2, that is 10. And how we write 10 into hexadecimal? A. And 0001. So this is 1. So the sorry. So the hexadecimal representation of this is 1A3 base 16. So this way you can convert your octal number into hexadecimal. Now it's easy because from octal we can easily write this binary representation. फटाफट આપણે લખી દીધું binary represent 301141006 and then we have converted into hexa. How? Make a group of 4. ચાર ચારના group બનાવતા ગયા આપણે, right? ચાર ચારના group એને બનાવતા ગયા and then we'll get the hexadecimal. If you have a fraction number, dot પછી number હોય, make a group like this. આ રીતે group બનાવવાના, right? From here you will start here. Okay, અહીંયાથી start કર્યું point થી આ રીતે. So here you need to start like this. Got it? Okay. હવે આ hexadecimal ને octal માં convert કરવું easy થઈ ગયું, right? So this is the binary representation of it. So what is the binary representation is 10100101 and 1111. This is the binary representation of this hexa number A5F. Now I need to convert into octal. So make a group of 3. Now convert into number. 111 means 4 plus 2 plus 1, that is 7. 011 3. 001 1. 101 4 plus 1 5. So the octal representation of this is 5137 base 8. So just વિચારો કે આ વસ્તુ decimal થી તમે કરવા જાઓ, how difficult it is, right? You need to convert into decimal, then decimal to hexa. It will take time, but this is now easy. ફટાફટ થઈ શકે. Okay, so કોઈ પણ હવે નંબર સિસ્ટમ જે 2 ની પાવરમાં હશે 16, 32, 64, એ બધામાં તમે આ વસ્તુ અપ્લાય કરી શકશો. Okay, so we have seen the different conversion. 4 number system જોઈ. In that number system we have seen the different conversion. એકબીજામાં અંદર કઈ રીતે easily કરી શકાય, right? So that thing we have seen. Okay, so this is about number system. This is about your number system. Okay, there is another binary coded decimal number system as well, right? Let just me explain you that binary coded number system. So in that 8 digit, right, it will take 0 to 9. Okay, so it will represent your digit in 4 bits, in 4 bits. So 00 is 0000 and 9 is 1001. Okay, so your number that will be combination of 0 to 9. So એ શું કરશે, આમાં represent કરશે 4 બીટમાં. So assume you have a number, take 25. This is your number. If you represent 25 into binary, બાઇનરીમાં રિપ્રેઝેન્ટ કરો તો 25 ને બાઇનરીમાં રિપ્રેઝેન્ટ કરું તો શું આવશે? સો 25 આ બાજુ 2 નું ફોર્મ કયું છે? 2 that is 16 and here 32 એટલે 16 થી પ્લસ ચાલુ કરવું પડશે. 16 પ્લસ next is 2 8. So 25 minus 60, 25 minus 16 is 9. Okay, હજુ 9 ને કરવું પડશે એટલે 8 plus minus 1, that is 0 plus 0 plus 1. 16 plus 8 plus 1, 8 plus 1, 9. 16 plus 9, 25. Okay, so binary is 1 1 0 0 1. If you represent this 25 in BCD, binary coded decimal, then the number will be, for 5 it will take 4 digits, that is 0 1 0 1. 4 plus 1 5 means it will represent individual digit. Then 2 means 1 0, but it will add 0 0. So means it will take any digit and represent the digit into 4 bits. 4 bit मैंने represent करे, right? So how many bits are required here? Total 8, and in this case 1 2 3 4 5 આમાં 5, right? અહીંયા 8 bits જોઈએ, so 3 more bits are required. So in BCD, when you convert number into BCD, it will take more bits, right? That's why we usually prefer this binary representation. Okay, so this is about your number system and your practical 2, that is on this number system only, right? So what you need to do in your practical 2? So in your practical 2, like if you search online also, you will get this conversion system as well. So your task is to implement that conversion system only. Practical 2 નો task તમારો એ છે કે તમે conversion system બનાવો, right? So for this 4 number system that we have seen, kaya? Decimal, binary, octal and hexadecimal. So આ 4 માટેનું તમારે conversion system બનાવવાનો છે. એટલે what your system should look like. So whenever you run your system, it will ask in which number system you want to enter your number. Means decimal માં enter કરવું છે, binary માં enter કરવું છે, octal માં enter કરવું છે કે hexadecimal માં enter કરવું છે, right? It will ask. Once you enter that number, suppose I have selected binary, my number system કયું select કર્યું? Binary. So in that case it should allow me to enter only 0 and 1. 0 and 1 નું જ combination allow, કારણ કે binary માં એ જ allowed છે ને, other numbers are not allowed. So it should allow me that number only, 0 1, and also fraction value dot કરીને જે value આપી છે એ પણ allow થવી જોઈએ. Once I will enter that number, હું enter number finish કરું, then as a result it should give me another 3 representation. So your system will ask first in which number system you want to give your number. Once you enter that number, it can be whole number, fraction number, right? Floating point number can be there, and as a output it will convert that number into another three representation. આ ત્રણ રિપ્રેઝન્ટ બીજા ત્રણ રિપ્રેઝન્ટેશનમાં કન્વર્ટ કરવું જોઈએ, રાઈટ. સો યુઝરની ચોઈસ છે કઈ નંબર સિસ્ટમ સિલેક્ટ કરવી, એમાં નંબર આપવો એન્ડ એના સિવાયની બાકીની બધીમાં કન્વર્ટ થવો જોઈએ. એન્ડ ફોર ધીસ યુ કેન યુઝ એની લેંગ્વેજ, જે પણ તમે એમાં કમ્ફર્ટેબલ હોય. ઇવન PHP, એન્ડ્રોઈડ, iOS, જેમાં પણ કમ્ફર્ટેબલ હોય યુ કેન યુઝ દેટ. Okay, but you are not allowed to use direct library. Direct library means binary conversion માટેની બધાની direct library available હોય and you are directly including that library અને પછી directly એ library નો use કરો એટલે નંબર આપો ડોટ બાઇનરી તો એ બાઇનરીમાં કન્વર્ટ કરીને આપી દે, એવું નથી કરવાનું. For conversion you need to write a code. કે આ કન્વર્ઝન થાય છે એના માટે તમારે કોડ લખવાનો છે, રાઈટ. ઇટ વિલ ઇમ્પ્રૂવ યોર અન્ડરસ્ટેન્ડિંગ અબાઉટ નંબર સિસ્ટમ એન્ડ યોર કોડિંગ. This practical, right? So for division 2, 4C2, like I am taking 3 labs and 1 lab that was taken by Rusa ma'am. So આ ટાસ્ક તમારો પ્રેક્ટિકલ 2 છે. B2 C2 ની લેબ ગઈકાલે હતી, but I have explained right now what you need to do in this practical. Once we feel that એ ખતમ થઈ ગયું છે પ્રેક્ટિકલ કેવું, then on team we will float assignment કેને અપલોડ કરવા માટેનું એ જે પણ હોય, and in that you need to upload your practical. એ practical upload કરવાનો. We will evaluate your practical. એ તમે જે સમજ્યા છો કોડમાં ને બધી વસ્તુ અમે પૂછશું. કશેથી લઈને ડાયરેક્ટલી મૂકી દીધો and you don't know anything, એ નહીં ચાલે, right? You must be able to explain your code thoroughly કે આ શાની માટે છે, આ શાની માટે યુઝ કર્યું છે, એ બધી વસ્તુ. And there is no language barrier, you can use any language, right? Because rather than syntax, logic is very important. Okay, so this is your practical 2. Next lab જેની પણ આવતી હશે, so in that you need to perform this practical only. Okay, અને જેની C2 બેચની રહી ગઈ છે તો આ ટાસ્ક કરવાનો છે. So you can start your task. D2 ને અને B2 ને already explain થઈ ગયો છે. Sorry, not B2, A2 and D2. B2 ને કાલે લેબ છે. So now I will not explain you, but you need to start performing. Okay, so based on this you have a second practical. Okay, now let's move to the next one, that is complement. Okay, complement. This is not the complement that you receive, right? So why we use this complement? So complement basically simplify the subtraction operation and for logical manipulation. તમારે કરવું હોય તો એની માટે complement use થાય, right? So whenever you perform subtraction, actually performs addition. એ એડિશન અંદર પરફોર્મ કરે, રાઈટ, કારણ કે સબટ્રેક્શનમાં બોરો લાવવાનું ને એ બધી વસ્તુ દેટ્સ ડિફિકલ્ટ. સો ઇન્સ્ટેડ ઓફ ધેટ what your system does, it will perform addition. So addition એ રીતે perform કરે that you will get a proper result of your subtraction. Even for multiplication and all, it will perform the addition, right? So we'll see that both algorithm કે કઈ રીતે આખું તમારું મલ્ટિપ્લિકેશન એડિશનથી થઈ શકે, right? So the advantage of complement I have told you. that it will use to simplify subtraction and for logical manipulation. કંઈક નંબરને તમારે ચેન્જ કરવા છે આખા નંબરને ને એ બધા માટે તમારે કોમ્પ્લિમેન્ટ યુઝ થાય. Now there are two types of complement, r minus 1's complement and r's complement. What is r? R is radix, your base. જે આપણે નંબર સિસ્ટમમાં જોયું, r is radix or base. So for binary number, base is 2. Base is 2. તો એના કોમ્પ્લિમેન્ટ કયા થાય? r minus 1 means 1's complement and r's complement means base is 2. This is the r. So 2's complement. Right? Then for decimal mate base is 10. So this will be r minus 1 complement, r minus 1, and this is r. So this is 9's complement and this is 10's complement. Okay. So આ વસ્તુ આપણે જોઈએ કે કયા કોમ્પ્લિમેન્ટ પોસિબલ છે for that particular base radix. So for binary 1's and 2's complement, for decimal 9's and 10's complement. Now let's see the conversion. તમને આખી મેથડ પણ બતાવીશ and then we will see the shortcut method as well, right? And these methods are very important for your gate exam and all. So for r minus 1's complement, in this we will just see the equation. For r minus 1 complement, the equation is r raised to n minus 1 minus n. R, you know, it's a radix. Small n, number of digits in your, just wait. Okay, so your small n, that is number of digits in that representation. So if I take binary, so 1010 base 2, if I want complement r minus 1 means 1's complement of this number, then if I use this equation, then r is 2. Small n is number of digits in this number, means 1 2 3 4. So 2 raised to 4 minus 1 minus n means your number, that is 1010. 1010. Now look at this. Your number, capital N, this is in binary form 1010, right? Base 2. This r raised to n minus 1. This is in decimal form, right? 2 raised to 4, 16 minus 1, 15. So 15 is decimal. And this 1010, that is binary. So what you need to do? कोई कॉमन नंबर सिस्टम में તમારે કન્વર્ટ કરવા પડે. કોમન નંબર સિસ્ટમમાં તમારે કન્વર્ટ કરવા પડે આને, right? So what we'll do, you can convert into decimal or you can convert this into binary. So right now let's convert into decimal. 1010, 10 base 2, 10 base 10, 15 base 10. Answer is 5 base 10. Now remember this right now, that કોનું કોમ્પ્લિમેન્ટ શોધીએ છે, બાઇનરીનું. તો એ શામાં હોવું જોઈએ? In binary only. Right now we are getting answer in decimal. Now if you convert this decimal into binary, the answer is 101. 4 digit છે તો 4 હોવા જોઈએ, so આગળ 0. So this is one's complement of this number 1010, right? 0101. અને તમે બાઇનરીમાં બી કન્વર્ટ કરી શકો. સો 15 if you convert into binary, that is 8, then 4, 2, 1. 15 minus 1010. So if you subtract this, let's do it. 1 minus 0, 1. 1 minus 1 is 0. 1 minus 0 is 1. 1 minus 1 is 0. So you will get directly this one, 0 1 0 1. So this is one's complement. This is one's complement, right? Now equation for r's complement. Equation for r's complement, right? It's r raised to n minus n for n not equal to 0. અહીંયા એવી કોઈ વસ્તુ નથી, but here it's there, n not equal to 0. If n equal to 0 means your number is 0, then the r's complement is 0. Number 0 હોય તો r's complement directly 0 આવે, બરાબર? If n not equal to 0, then follow this equation, r is to n minus n. So now let's do for same number, 1010 base 2. So r, you know, it's a radix. So 2, small n, number of digit 1 2 3 4. So it's 4 minus capital N, your number 1010 base 2. Now this is 16, 2 raised to 4, 16 base 10. 1010 base 2. Now convert 16 to binary. 16, 8, 4, 2 and 1. Subtraction करવું હોય તો 1000 1010. If you perform subtraction, 0 0 minus 1 not possible, so you need to take borrow. અહીંયાથી પણ નથી possible, અહીંયાથી પણ નથી possible, અહીંયાથી yes. So this will be 0 and here it will give 2. પણ હજુ આગળ પાસ કરવાનું છે borrow, so this will be 1, this will be 2. Still અહીંયા પાસ કરવાનું છે, so this will be 1, this will be 2. So 2 minus 1, that is 1. 1 minus 0, 1. 1 minus 1, 0. 0 minus 0, 0. Right? So if you want to represent 2's complement of 1010, then that will be 0110 base 2. Take 4 digits only. Okay, 0110, 2's complement. Now આ નંબરનું વન્સ કોમ્પ્લિમેન્ટ શું હતું? 0101. Just wait. Right, so what is the ones complement of this number 1010, it's a 0101. So 0101. Now add 1. Now 1 add karo. Now what will happen? 1 plus 1, that will be
0.
0
Carry 1.
1. Carry 1, right? Yes, carry 1. 1 plus 0,
1.
1. 1,
1.
1
0.
and 0. What is this? Uh, this thing 0 1 1 0. આજે આન્સર મળ્યું શું આવ્યું આપણને 0 1 1 0. So r's complement, r minus 1's complement, if I add 1, શું મળે છે મને? r's complement, right? એડિશન તમે 1 plus 1 કરો 0 આવે છે. 0 1 કઈ રીતે 1 plus 1 કરો એટલે શું થાય 2. પણ 2 તો ડેસિમલ થઈ ગયું. બાઇનરીમાં 2 ને કઈ રીતે રિપ્રેઝેન્ટ કરાય 1 0. એટલે 0 મેં અહીંયા લખ્યું and 1 carry. Okay, if you have a 3, maximum આ પોસિબિલિટી થાય 1 plus 1 plus 1 carry 1 આવે અને બંને નંબર 1 છે તો આ શું થાય 3. So 3 ને રિપ્રેઝેન્ટ કરવો તો કઈ થાય 1 1. So in that case આ તમે જે પોઝિશન હોય ત્યાં મૂકો and 1 will be carry, right? આ પ્રમાણે એડિશન થયું. હવે અહીંયા જે ઓબ્ઝર્વેશન આવ્યું છે, so in this r minus 1's complement, so for 2 this number 1010 in binary, the 1's complement is this. Now in that 1's complement we have added 1 and the result is 2's complement, and this is true for any complement. તો આવું થયું કઈ રીતે? Let's see this. So r's complement, the equation is r raised to n minus n for n not equal to 0. 0 હોય તો ડાયરેક્ટ 0 મૂકવાનો છે, right? So r raised to n minus n, this is equation for r's complement. આ કઈ જાદુ નથી, આ તમને હમણાં બતાવું એટલે ખબર. r raised to n minus n. So now r raised to n minus 1 plus 1 I add કરું આવી રીતે. So minus 1 plus 1 બંને એડ કરું તો આ બંને કેન્સલ કરું તો means r raised to n minus n મળે. Now I am writing in different form. r raised to n minus 1 minus n plus 1 means આ minus 1 ને મેં આગળ લીધું. Now see this. Now got it? What is this? This is r minus 1's complement. N equations hai. See this, r raised to n minus 1 minus n. Now if you add plus 1, it will give you r's complement, right? So that's why if you add 1 into r minus 1's complement, what you will get? You will get r's complement. You will get r's complement. Okay, any doubt in this? Any doubt in this? No doubt? Anyone know the shortcut method?
Yes, sir.
Okay, what is that?
किसके लिए?
For r's complement, for 1's complement.
जहाँ पे 1 होता है वहाँ पे 0 कर देने का, जहाँ पे 0 होता है वहाँ पे 1 कर देने का.
Okay, so you need to convert 1 into 0 and 0 into 1, right? Now why वो क्यों करना पड़ता है? ऐसा क्यों होता है?
मतलब मेथड तो डिफरेंट है जैसा आपने दिखाया, पर ये तो शॉर्टकट है. मतलब
yes, shortcut is correct, but shortcut means वो किसी इंटरप्रिटेशन से आया है. कि ये है इसलिए हम ये कर सकते हैं. So जो इसने बोला means that is correct, right? This number if I want to convert into ones complement, मुझे ones complement convert करना है. So what is it? Just replace this 0 with 1 and 1 with 0. See this. 0 था वहाँ पे 1 आ गया, 1 था वहाँ पे 0 आ गया, right? But ये क्यों हुआ? Why? Now if you see this process, અહીંયા subtraction જે આવ્યું, right? The subtraction 15 is 1111 minus your number 1010. Now if you have any number, if you subtract that number from 1, if you subtract that number from 1, you will get the opposite number. 1 minus 0 करोगे तो 1 आएगा, 1 minus 1 करोगे तो क्या आएगा? 0. Opposite number 1 में से subtract करो तो ये क्या हुआ है? The same thing that is happening here, right? You are subtracting your number from 11111 और यहाँ पे वही आएगा ऐसे ही 1111. If it is a 6 digit तो यहाँ पे कोई भी 6 digit होगा तो यहाँ पे जो नंबर आएगा वो ऐसे ही आएगा कि ये 61 हो गया, right? So whenever you are subtracting your number from 1, you will get the opposite number, it means opposite digit. Right now we are talking about 2's complement only. So opposite digit आपको मिलेगा. So ये 1 आएगा, ये 0 आएगा. So 0 को किस में convert किया? 1. 1 को किस में किया? 0. That's why we are directly telling that कि जो भी नंबर है उसको 0 को 1 में कन्वर्ट कर दो, 1 को 0 में कन्वर्ट कर दो, right? Now for 2's complement, एक जो अभी मैंने दिखाया कि इसमें 1 ऐड करो तो भी आपको डायरेक्टली मिल जाएगा और डायरेक्टली लिखना है तो if I want to write it directly, then how you can write it? Okay, let me tell you. So what you need to do, take your number, this one, from least significant bit start observing, right? Unless and until you will get a different digit than 0. 0 સિવાયનો કોઈ પણ digit means 1, right? Until you get first 1, until you get first 1, keep number as it is. So 1 0, 0 as it is, 1 as it is. Now for remaining number, convert 0 into 1 and 1 into 0. So 0 into 1 and 1 into 0. Your 2's complement. Again, start from right side, your least significant bit. Keep 0 as it is until you get first 1. First one આવ્યો, first one આવ્યો. Keep as it is. Change the remaining digit. How? 0 to 1, 1 to 0. So I have done it. What is that? 2's complement. હવે આ વસ્તુ કઈ રીતે આવી? આવું મેં કઈ રીતે કીધું? So see this. If you have a number, ક્યાં સુધી મેં કીધું? 0 ની આગળ 1 ના આવે ત્યાં સુધી as it is. So 0, 0, right? So અહીંયા 0 છે ત્યાં સુધી as it is, right? કારણ કે આગળ શું આવવાનું છે? 0 જ આવવાનું છે. So as it is, 0 as it is. Now first one હશે. So means here અહીંયા 0 હશે અને એ કોઈકની જગ્યાએ બોરો લેશે. So એ બોરો લેશે તો અહીંયા જે નંબર આવશે એ તમારું રેડિક્સ આવશે. And when you subtract it, 2 minus 1, you will get 1 always for binary. એટલે આ નંબર જે હશે આટલા લાસ્ટ એ ચેન્જ નહીં થાય, as it is આવશે. But now for rest of the digit, આ જે આગળના 2 છે એ શામાંથી સબટ્રેક્ટ થાય છે 1 માંથી. બંને શામાંથી સબટ્રેક્ટ થાય છે 1 માંથી. એન્ડ એઝ વી હેવ સીન હિયર વી આર સબટ્રેક્ટિંગ ફ્રોમ 1. તો એ શું કરશે? 0 હશે તો 1 થઈ જશે, 1 હશે તો 0 થઈ જશે. So that's why I told you that 0 હશે તો 1 કર દો, 1 હશે તો 0 કર દો. So this is shortcut for 2's complement. Okay, so I have given you shortcut with reason. Okay, કેમ એ વસ્તુ થાય છે. And this is, if it is 0 then you need to put directly 0. તમારે directly 0 મૂકવાનું છે. Okay. Okay, so this is for today's lecture. We'll discuss more example. I will give you example and be ready with your note and pen and paper. You need to solve, and a solve કરશો doubt આવશે, we will solve at that time. Okay, any doubt in this?
No, sir.
Okay.
No, sir.
Okay, so let me stop recording.